2018, number 4, part B, says explain why there must be at least one time between 2 and 10 such that h prime of t equals 2. So anytime they're saying explain why there has to be at least one point where a derivative is something, all those things are keys that tell you that you're looking at mean value theorem. So you want to remember that the mean value theorem says that if a function f is continuous on the closed interval and differentiable on the open interval, then there exists a point C, and C is in the open interval, such that f prime of C is equal to f of B minus f of A over B minus A. That is to say that the instantaneous rate of change, or the derivative, is equal to the average rate of change, or the slope. So what we need to do is say, we need to find a place where this average rate of change, we need that to equal 2 somewhere. All right, so where is that going to equal 2? So I can look at, like, your first instinct when I see the intervals from 2 to 10, my first instinct is, can we use 2 and 10, right? So if I look at 2 and 1.5 and 10 and 15, so if I did, just as an experiment, like a thought experiment, 15 minus 1.5 over 10 minus 2, well, I can tell right away because of the 0.5, that's not going to be 2. So what I need to do is find an interval where it equals 2. All right, so I could try, 7 minus 5 is 2, so I'd have 2 over 5. No, that doesn't work. 5 and 3, 6 and 2. 5 minus 3 is 2. 6 minus 2 is 4. Oh, so 4 over 2. Yeah, that would work, right? If I have 4 over 2. So let's focus in on that interval between 3 and 5. And so because I know that 6 minus 2 over 5 minus 3 is equal to 4 over 2, which is 2, and that's the derivative that I'm looking for. So all that is sort of like just my thought process going into this. And then we need to say, all right, in order to use the mean value theorem, like all of this is just, my thought, my strategy, right? Things I should think about. So now let me actually write the solution. So for the solution, first of all, you need to get these criteria satisfied. They're going to be looking for that. You need to show that the criteria is satisfied, and you need to cite the theorem. All right. So a most common mistake that people made on this is not showing that the function meets the criteria. So your function is h, and we know that that function is twice differentiable. Since it's twice differentiable, that means it's differentiable. And if a function is differentiable, it's continuous. They're always looking for you to know that if a function is differentiable, then it is necessarily continuous. And if it's not continuous, it's not differentiable. So because this function is twice differentiable, it's therefore differentiable. Since it's differentiable, it's continuous. Now, they don't say it's twice differentiable on a certain interval. That means it's differentiable for all real numbers. But we need to specifically refer to this interval. So what I would say is h is differentiable. We don't need to say twice differentiable. We only need to be once differentiable. Is differentiable and therefore continuous. And then it would say, and in particular, is differentiable and continuous on the closed interval that I'm going to use. And the closed interval I'm going to use is 5 to 3, so 3 to 5. Now what I'm going to do is I'm going to say it's differentiable and continuous on the closed interval. That way I've already covered that it's differentiable in the open interval and continuous in the closed interval. If you want, you could separate those two, but I don't think that we need to. All right, so then once you got that, then you're going to say, therefore, you should say the mean value theorem applies. We've said this, so we probably could get away with not saying it, but I would mention it. The mean value theorem applies. So there is, you can be cool and use the there exists symbol like that. They'll know what it means, but if you want to be explicit and not learn that symbol, you could just say there is a point in the open interval 3, 5, such that h prime, and we want to put it, I just use general function notation. We need to put it in terms of the specific function they gave us. So that h prime of t equals h of 5, and I would write this out, h of 5 minus h of 3 over 5 minus 3, which equals 6 minus 2 over 5 minus 3, which equals 2. And then we've established what they wanted us to establish. All right. And so you could be like really a little bit nuts and say, okay, but they said, explain why there's this type of value on this bigger interval, and I've showed that there's a value in this smaller interval. You probably can be done here, and this is fine. All right. But I would be inclined to add, and this point lies also lies in the interval from 2 to 10, right? It lies in 2 to 10 because it lies in 3 to 5, which is a smaller interval. So this is probably, a little bit of overkill, right? This last line. The critical things to have, you need to show that h is differentiable and therefore continuous. You need to say it's differentiable and continuous in the closed interval, or differentiable in the open interval, continuous in the closed interval. You need to say the mean value theorem applies, and you need to say there is a point in the interval such that, and you need to say h prime equals this equals 2. So that's what we're going to need for that section. So it's mean value theorem. That's part B. Most people got that. Just make sure you get all the details. Make sure we have the criteria, the theorem, and the conclusion.